All right, ladies and gentlemen, our topic for the lesson today is solving one-step equations. Monday in class, we talked about how to use mental math to solve equations, and I think you guys are fairly comfortable with that. So now we're going to look at a little bit more complicated of a method to solve equations, but this method works for every equation you're ever going to have to solve. You can't always use mental math to solve an equation. Now, I'm going to be asking you to do things a certain way today, and you may be like, I don't really need to do it that way, Mrs. Ott. I can do it mentally in my head. And what I'm going to tell you is that you really need to do it my way, because in about 2 days, you're going to start getting some really complicated equations that you can't do in your head. So today we're going to be solving, excuse me, we're going to be solving one-step equations, so put that as the heading on your page. And our objective is I can solve one-step equations using inverse operations. And I want you to put this part, not mental math, because if by the end of the lesson you're still using mental math, you aren't doing it correctly. So now we have to talk briefly about what an inverse operation is. So write this vocabulary word down. An inverse operation are two operations that undo each other. For example, the inverse operation of addition is subtraction. If I have, I don't know, 10 cookies and I add 3 cookies and then I subtract 3 cookies, well, I'm left with however many I started out with, 10 cookies. So addition and subtraction are inverse operations. They undo each other. We also have multiplication and division that are inverse operations. So these go with each other, and they're going to be very important for solving equations. There's actually other inverse operations. For example, square root is the inverse operation of something squared, but we're not going to be using those for this current unit, but there's lots of inverse operations. Okay, so now what do we actually do with these inverse operations? Let's take, for example, this equation, x plus 2 equals 9. We are going to use the concept of inverse operations to solve this and figure out what x is. Now, I know that most of you are already saying, hey, Miss Ott, x equals 7 because 7 plus 2 is 9. And yes, that is true, but that is not the way that I want you to be doing equations anymore, okay? We have to take it to the next level. So when we are undoing an equation using inverse operations, I'm going to look at what is happening to my variable. My variable in this case is x, and x is being added to 2. So we have plus 2, and we need to undo that plus 2. On the previous page, we talked about the inverse operation of addition is subtraction. So what I want you to actually show when you're solving these questions is right underneath where it says plus 2, I want you to write minus 2. And I think you guys have probably done things like this before, but I'm going to tell you I am extremely picky about the way you write it. Not only are you going to put minus 2 right under this side of the equation, we are going to take that and write it over here as well. It's kind of like this is a balance, all right? And whatever you do to one side, you have to do to the other side to keep everything even. So if I subtract 2 from this side to cancel out this adding 2, I'm going to subtract 2 from this side, and I end up with 7 on the right-hand side of my equation. My plus 2 and my minus 2 end up canceling each other out, and I'm left with x. An equal sign goes in the middle, and we get x equals 7. I want to see work like this on every question you solve using inverse operations. It's really important to me, guys. Okay, so now let's do another example. We have x plus negative 3 equals 13. There's a couple different ways to do this one, guys, and bear with me because it might be a little confusing to you at first. We talked about the fact that the inverse operation of addition is subtraction. So I can go in here and I can say, okay, well, if I'm adding -3, I can subtract -3 from both sides, minus -3. And then that is going to have these two cancel. And over here, what do we always do with subtraction, guys? We change it to adding the opposite. So this becomes 13 plus 3, which gives me 16 on this side. I'm left with x on the left-hand side, so x equals 16. You might want to rewatch that part of the video because it can confuse people. I'm going to show you another way I could think about doing this, and that is using the concept of additive inverses. You know we've talked about those before. If I am adding -3, well, the additive inverse of -3 is just +3. So if I write down the additive inverse on the left-hand side, I can write the additive inverse on the right-hand side because it has to be fair. This -3 and +3 cancel each other out, leaving me with x on the left and 16 on the right. Both ways of doing this gets me the same answer, so you need to decide which way you're most comfortable with. I'm okay with either of them as long as I see your work. Please take a moment and rewatch that. Those two different ways of solving this problem are really important for you to kind of see and get a sense of. And we're going to be talking about this in class tomorrow. But it would really benefit you guys if you can, review that a couple times. All right, let's look at another example. So if I have 8 plus y equals 10, I have to do a balance here. Whatever I do to one side, I have to do to the other. Make sure you're writing all these examples down. You know that, right, guys? Nice and neat so I can read them. These are in a little bit of a different order than before. You're used to seeing the variable first. So you could do a couple things. You could say, you know what? I'm going to rewrite this as y plus 8. And I can do that because of the commutative property of addition. And then I'm going to use inverse operations. This is adding 8, so I'm going to subtract 8. Subtract 8. On the left, my 8 and my -8 cancel, and I'm left with y. And on the right, 10 minus 8 is 2, giving me an equal sign. So y equals 2. That's one way you could solve this problem. Another way is I could use what I know about additive inverses. If I want to get rid of this 8, I can do, okay, well, -8 is the additive inverse of 8. -8. Got to do the same thing to both sides. My 8's cancel. I'm left with y equals 10 plus -8. That's going to give me +2. Or 10 minus 8 is going to give me +2. You know how you guys always ask, is this subtraction or is it a negative sign? And I always say, well, it's kind of the same thing. It's because 10 minus 8 is 2. 10 plus -8 is 2 also. All right, how many of you guys are confused? I think that probably a few of you are, but we're going to get through it and we're going to do so much practice on this. Here's another one. Oh, this one's different, Mrs. Ott. This one has 6m equals 30. There's no addition here. There's no subtraction here. But anytime there's a number right next to a variable, they are multiplying. So this is actually 6 times m equals 30. And if we go way back, all the way back here, the inverse operation of multiplication is division. So that means in order to undo this, I have to take both sides and divide by 6. I have to do it to both sides to keep the balance equal. When I do that, my 6 times m and then divided by 6, that cancels out the 6. So all I'm left with is m. And then 30 divided by 6 is 5. So there you have your answer. All right, how are you feeling about these things? Pretty good? All right, I have 15 seconds left before I hit 10 minutes. So I'm going to do this one super quick. P over 4, that's like a fraction equals -3. A fraction bar is the same as division, so to undo this, I have to multiply both sides by 4. Same thing to each side. That's going to cancel out these 4's, and I get P equals -3 times +4 is -12. Let me give you a reflection question, guys. I want you to do this one. Put your answer in Edmodo when you turn in your reflection, and don't forget about negatives. Don't forget all of your negative rules because you're going to need them on this problem. Use inverse operations, give it a shot, and I will give you some feedback after you post it in Edmodo. All right? Thanks, guys. Have a good night.